Good morning, doctor. My name is Praveen Raj Ravi. Today, I would like to present about the assignment digital filtering of audio signal. So, I got the audio to the two for my assignment. So, the main objective of this assignment is to detect and remove these unidentified and unwanted noise signals. So, let's see the original audio, which is having noise and interruptions. Okay, here we are having two digital filters, which is finite impulse response, which is FIR, and infinite impulse response, which is IIR. So FIR filters have a finite duration response to an input signal, meaning they settle to zero after a certain number of samples. Then they are inherently stable and exhibit a linear phase response, making them ideal for applications requiring phase accuracy. Also, FIR filters require higher orders for sharp cutoffs, which is increases computational costs. And then IIR. IIR filters have an infinite duration response to an input signal due to feedback in their design. They are computationally efficient, requiring fewer coefficients compared to FIR filter for similar performance. And lastly, IIR filters may introduce non-linear phase response and require careful design to maintain the stability. Now let's go for the plot and filtering audio output for FIR filter. Here we can see the time domain signals with original audio and after filtered audio. So the amplitude of original signal is dense and shows the presence of noise, making the waveform appear more chaotic. And then FIR filter audio signal, the filtered signal appears smoother with less high frequency noise getting successful noise attenuation while maintaining overall signal structure. Here we can see the spectrum signal with original audio and FIR filtered audio. So the frequency spectrum shows proximity peaks and noise components across the range, especially within the 200 Hz and to 2 kHz band for the original audio. And after filtered, the spectrum of filtered signal reveals a significant reduction in the amplitude of frequency within the target noise band, which is 200 Hz to 2 kHz, while the other frequency components remain relatively unaffected. And then here is the spectrograms. So from the original audio, the spectrogram shows a wide range of frequency with significant noise distributed across the spectrum, particularly between 200 Hz and 2000 Hz. And then after applying FIR filter, the noise within the targeted range, which is 200 to 2000 Hz, is significantly attenuated, leaving the spectrogram with much less noise energy in this band while preserving the lower and higher frequency component. Now let's see the plot and filtering audio output for IIR filter. Okay, now let's see the time domain frequency output for the IIR signal. Okay, here we can see the original audio and the IIR filtered audio signal. So, firstly, the waveform exhibits chaotic and dense amplitude fluctuations, reflecting the presence of noise throughout the audio signal from the original audio. And then the filtered waveform appears smoother with reduced high frequency noise. And then the main structure of the audio signal is preserved while the noise attenuated. Okay, now let's see the frequency spectrum output for the IIR filter. So the original audio gives the frequency spectrum shows significant noise components across the entire range with prominent peaks, especially in the lower frequency and near 5000 Hz. Also, after applying the IIR filter, the noise components are greatly attenuated, especially in the higher frequency range. The filter signal retains only the essential frequencies while reducing unwanted noise. And then let's see the spectrogram. So the from original audio, the spectrogram reveals a wide distribution of noise across time, particularly concentrated in the frequency range up to the 4 kHz, making the spectrogram appear dense with energy in multiple bands. And then the spectrogram of the filtered audio shows a significant reduction in the noise energy, particularly in the higher frequencies. The lower frequency component are preserved, indicating successful noise suppression by the IIR filter. Now let's see the after filtered audio for FIR and IIR. So I have identified few differences between FIR and IIR in the while the filtering progress. So the FIR is more stable than IIR. IIR also can be stable, but it can be unstable if not designed well. Also, FIR is linear phase response, but the IIR is not linear phase response. And lastly, FIR is easier to design, but IIR is a bit complex to design. As a conclusion, the effective noise reductance at both FIR and IIR filters successfully reduced noise in the targeted frequency range of 200 to 2000 Hz, significantly enhancing audio clarity. And then FIR filters provided precise control, linear phase response, and stability, but at a higher computation cost. IIR filters offered efficient noise reduction with lower computational demands but introduced the non-linear phase response. The choice of filter type and design parameters is crucial and depends on the specific requirements such as computational efficiency, phase linearity, signal integrity. So from this experiment, I felt that FIR is more recommendable compared to IIR. That's all from me. Thank you, doctor.